Hello, welcome to section 3.1. This is our first section on the module covering inequality and poverty. So in this section, we're going to go over a couple of different ways to measure inequality. So we'll take a look at size distributions, the Lorenz curve, and the Gini coefficient, and then some of the issues with using those metrics. So I do this a little bit differently this time. We're trying a Zoom recording, and then I'm going to share your screen because there's a few things that I actually want to use a whiteboard for here. So that's why we're doing it. But okay, so to begin with, let's actually just go straight to the Canvas notes. And hopefully you can see that now. This is basically, what you have on your Canvas page, and this is section 3.1 on measuring inequality. So, the whole purpose of this is we want to be able to get some kind of way to look at and measure the degree of, in this case, we're just looking at income inequality, but you could actually use these same tools to measure inequality in any number of different things. You could look at it as education inequality, health inequality, because essentially what we're going to be doing is we're going to be effectively ranking people in the country. If it's on the case of income, we'll rank them from the lowest income to the highest income, or if it's the case of health, the worst health to the highest health, depending on how you're measuring health, so on and so forth. So just in the case of inequality, we're using this as an example, but it's important to note that you can actually use these tools to measure any number of different kinds of inequality. The first one we're going to take a look at is just a size distribution. And this is basically the building block for the next two tools that we're going to be using. So a size distribution, basically, you take everybody in the country and you order them from the lowest level of income to the highest level. Here, let's say there's 10 people. Maybe there's 1 million people in the country. Each one of these people represents 10,000 people. Whatever it is, right? So just for the sake of simplicity, let's say that we rank each of these 10 people and we order them based on their income. And so person one has $36, person two has $64, so on and so forth, up until the richest person, person 10, who has $570. Okay. So if you add up all of the incomes for each of these individual people, you end up with 2,000. And so once we have this total, then what we can do is we can figure out how much income, what share of total income does each of these individuals have. So person one, for example, has $36, and $36 represents 1.8% of the total income of 2,000. Person two has $64. $64 represents 3.2% of the total income of 2,000. So on down the line until you get to person 10, whose $570 represents 28.5% of the total income. Now, since we have 10 people in this example, each person thus represents 10% of the population. And what we have here is the bottom 10% of income earners, the second 10%, the third 10%, all the way up until the top 10%. If we'd split this across 100 people, this could have been the top 1%, the bottom 1%, so on and so forth. If this was 5 people, then it would be the bottom 20%, so on and so forth. So here, what we have is called income deciles. Basically, it's splitting up the population into 10% groups. And so nice things about this is that if I know how much money is being held by the bottom 10%, and I know how much is being held by the second poorest 10%, then I can add up their individual income shares to figure out what the cumulative share of income is held by the bottom 20%. So if the poorest 10% has 1.8% income, and the second poorest 10% has 3.2% income, then add those two together, then what we see is that the poorest 20%, basically persons 1 and 2, have cumulatively 5% of income. All right. So effectively, if you want to compute the cumulative income share, you take the income share at the bottom. All right. So that is both the individual income share and the cumulative income share just for that first person. And then you add to that cumulative share how much money is held by the next 10%. And then that gives you this cumulative share. So here we go from 1.8% plus 3.2% gives us 5%. If I want to know how much income is held by the bottom 30% of the population, I can take that 5% held by the bottom 20%, and I add to that the 3.9% held by the next 10%, and that gives me a cumulative income share from the bottom 30% of 8.9%. Okay, so the cumulative income share, once we add up all of the groups together, has to add up to 100%. Basically, that just means that 100% of the income is held by 100% of the population. And so this is useful in that it something we can use to compute what are sometimes called sort of decile ratios, or sort of ratios of the size distribution, that allow us to kind of get a quick idea of how much income is being held at the top relative to the bottom. So, for example, a popular sort of ratio that is oftentimes computed is known as the 20-40 ratio. So the 20-40 ratio basically says, what is the share of income held by the richest 20% as compared to the share of income held by the poorest 40%, right? And so we know that the richest 20% are holding collectively 22.5 plus 28.5, which is going to be equal to, what is that, 51% of income. And then the poorest 40%, we know, hold 14% of the pot of income. So we know that the richest 20% hold 51% of income. The poorest 40% hold 14% of income. If you take the ratio of those two, then what we end up with is that ratio is 3.6. The richest 20% hold 3.6 times more income than the bottom 40%. Another commonly used statistic is the 10-20 ratio, which is, as you would guess, the share of income held by the richest 10% compared to the share of income held by the poorest 20%. So we know the richest 10% hold 28.5% of income. We know the poorest 20% hold 5% of income. So take the ratio between those and you end up with 5.7. So in this hypothetical example, the richest 10% hold almost 6 times more income than the poorest 20%. So the nice thing about doing these ratios is, because they're ratios, they don't have any units, basically. And you have the same number, same kind of number in the numerator as in the denominator, the units cancel out, which is really useful because that allows us to make cross-country comparisons. All right. So we can compare, for example, income inequality in a country like Pakistan to income inequality in a country like the US, even though obviously they use different currencies. There's a whole bunch of differences in average income. But we can at least say, in terms of the share of income held at the top to the bottom, we can make a meaningful comparison between those two countries. Okay, so size distribution is certainly useful, but it's a bit much when you're looking at all those numbers to immediately be able to kind of get a sense of inequality. Something that can be a little bit more useful is what's known as a Lorenz curve. So a Lorenz curve basically is a visual representation of a size distribution. So what we're doing with the Lorenz curve is simply graphing out the cumulative income shares held across the population. So basically, here's an example of a Lorenz curve. And we're going to go through and actually draw a couple ourselves. But basically what we do is we take the population share on the horizontal axis and we map that against the cumulative income share on the vertical axis. So what we're going to do is we're going to say, all right, how much income is held by 10%? How much income is held by the bottom 20%, by the bottom 30%, by the bottom 40%, so on and so forth, until we get to 100% of the population holding 100% of the income. So whenever you're drawing a curve, there's always going to be 2 points that are on every Lorenz curve. The first point is that 0% of the population holds 0% of the income. And then the second point is that 100% of the population holds 100% of the income. Now, the Lorenz curve simply is going to say, all right, the bottom 10% of the population holds, if we go back up to this table, 1.8% of income. And so we have this point right here, 10% of the population holds 1.8% of the income. The bottom 20% of the population, remember we need to go up here to the cumulative income share, they hold 5% of income. All right, every time I teach this class, people make this mistake. When drawing the Lorenz curve, the individual income shares, not the cumulative income shares. Make sure that you're plotting out the cumulative income shares. If you plot out the individual income shares, I'll tell you, you're going to know you made a mistake, because your Lorenz curve is not going to end up at this far sort of northeast point here at 100 to 100. Okay, so anyways, 20% of the population holds 5% of income, so that's our next point. And we just keep on plotting out points. 40% of the population, for example, holds 14% of income. And so that's why we get this point right here. If we want to get 60% of the population, we go back up, we see that they hold 27% of income. And we keep on plotting out these points until we have this blue line that's right here. Now, the reason why Lorenz curves are useful is that we compare them to sort of two extreme situations. The first extreme is the case of complete and perfect equality. So complete equality means everybody has the exact same amount of income. And if everybody has the exact same amount of income, that means that the poorest 10% of the population has 10% income. The second poorest 10% has 10% of the population, so on and so forth, which means that 10% of the population would have 10% income. 20% of the population would hold 20% of income. 40% of the population would hold 40% of income, so on and so forth. And so we draw this line of equality as representing the case where there is perfect equality. The other extreme that we want to consider is the case where one person in the country has all of the income, everybody else has zero. So if you can imagine what the Lorenz curve for that kind of situation would look like, basically it would be along this horizontal axis at a height of zero, because basically everybody has nothing, except for this very last person where it would shoot up to this last point right here. So basically it would just be this whole triangle with a base of the horizontal axis, a height of the vertical axis, and basically just that one point. Everything's along zero until you get to the last person, and then that's basically all the income is there. So those are our two extremes. All right. The actual Lorenz curve for a country is going to be somewhere in between those two extremes. The further away it is from the line of equality, the more income inequality we have in that country. All right, so let's go through and actually go through a couple of different examples and actually draw this there. So I'm going to pull up PowerPoint here and hopefully let's see if this works. Looks like I'm still screen sharing. That's good. And so what I've got here, move my little camera. All right. Oop. That works. Basically is just, a blank diagram or any kind of quiz. I'm going to give you this blank diagram that's there. And the first thing we always want to do whenever we get one of these kind of diagrams is to draw the line of equality. The line of equality, remember, is going to be a line. Since it is indeed a Lorenz curve itself, that's always going to have those same 2 points that every Lorenz curve has at 0, 0, and at 100, 100. And it's just going to be a line, a straight line that is connecting those 2 points, which incidentally has a 45-degree angle from the origin, if that makes things easier. Okay, so that's our reference point. So I've got one example of a size distribution, and it's a simple one. It's only, rather than using income deciles, what we're using is income quantiles, so only 5 groups instead of 10. You could also do income quartiles, would be 4 groups instead of 5, but in this case, we'll do these 5 groups. And I've got the income shares held by each of those groups, as well as the cumulative income share held overall. So the bottom 20% hold 5% of income. So the way that I draw this is I find, okay, the bottom 20% on the horizontal axis, and I know they have 5% of income, so I'm going to find right here representing 5%. Remember, always want to have the point 0, 0, and 100, 100 on your Lorenz curve. The next 20% hold 10% of income, which means that the bottom 40% of the population hold a total of 15% of income. So the bottom 40% hold 15% of income. Next, the bottom 60% hold 30% of income. Again, I'm doing the cumulative shares, not the individual income shares. Finally, the bottom 80% hold 55% of income. So 80%, you find 55 right here. And now I've plotted out all the points on the Lorenz curve because, of course, the bottom 100%, or basically everybody, has 100% of the income. And so when you're drawing your Lorenz curve, just connect these dots. Apologies for the little spikes that are there. That's like my shaky hand with the stylus. Okay, so that's an example of a Lorenz curve. And you can see it's certainly not perfect equality. It's not on the line of equality. But where it's really useful is when we can compare this, for example, to another country. So here I've got another country, a different size distribution. And as we're going to see, this country has more inequality. And so again, always have the same 2 points, 0, 0, and 100, 100. Excuse me. Now let's plot out the rest of these. 20% in this country, only 2% of income. The bottom 40% has 7% of income. Should be right around there. The bottom 60% have 15% of income. Bottom 80% only have 30% of income. And then finally, of course, everybody in the country has 100% of income. So if I were to connect these points, okay, what I'll have now is a different Lorenz curve. And you can see that the Lorenz curve for country A is a lot closer to the line of equality than the Lorenz curve for country B. And so if I were to quickly take a look at these two countries, I could just immediately say, okay, yeah, there's more equality in country B than there is in country A. So that's kind of the nice thing about this sort of visual representation is it gives us this reference point of the line of equality and allows us to see immediately how close a country is to it, how far away a country is from it. Again, we're not saying anything about whether good or bad. We're simply using this to measure inequality. Okay, so let's go back to the Canvas notes. And here again is just another example of utilizing these Lorenz curves to compare income inequality. Over here, the panel in A has, a Lorenz curve that's super close to the line of equality. I don't even think that's like Sweden, like low levels of inequality. There's probably no country that actually looks like that. And then over here in country B, you have obviously a lot more inequality where, the bottom of the income distribution holds significantly less income than the top of the income distribution. Okay, so the next thing that we're going to do is building upon what we've got so far with our size distributions and the Lorenz curve, and that is to compute a single numerical statistic that summarizes inequality. So basically, this is something that's going to utilize that distance between the line of equality and the Lorenz curve to come up with a number that we can compare between countries that summarizes inequality. All right, so this is called the Gini coefficient, and both the Lorenz curve and the Gini coefficient are named after the economists that came up with these. And so the way that we compute the Gini coefficient, and I'm not going to ask you to actually calculate it, but I do want you to know the general idea of how it's computed, is that the Gini coefficient is going to be the area that is between the line of equality and the Lorenz curve multiplied by 2. Okay, so the bigger this area, the larger the Gini coefficient is. And why do we multiply by 2? Actually, this can help us understand the idea behind constructing the Gini coefficient. So first off, think about what would the Gini coefficient be for a country that has perfect equality, okay? A country that has perfect equality, their Lorenz curve is the line of equality, which means that there's no area whatsoever between the line of equality and the Lorenz curve. So that country would have a Gini coefficient equal to 0. Now, suppose that we've got a country that is the highest level of inequality imaginable, where, remember, one person has everything, everybody else has nothing, right? And there's no country like that, thankfully, but, imagine now, just as another extreme, that we have that situation. The Lorenz curve for that country, remember, would basically be running along this horizontal axis up to the very end, and then that one person would have everything. And the area between the line of equality and the Lorenz curve is simply going to be this triangle that has a base of the horizontal axis and a height of the vertical axis. Now, the formula for the area of a triangle is 1/2 the base times the height. So the base of this diagram is 100%, which is also equal to 1. The height of this triangle is, again, 100%, which is equal to 1. So the area of this triangle is 1/2 times 1 times 1, which is equal to 1/2. Okay, so for this area A, for the most unequal society imaginable, is equal to 0.5. So just to make things on a 0 to 1 scale, we multiply this area A by 2 so that the Gini coefficient for the most unequal country that we could ever imagine would be equal to 1. So for every other country in the world, the Gini coefficient is going to be some number that's between 0 and 1. No country has a Gini coefficient of 0 because there's no country that has perfect equality, and no country has a Gini coefficient of 1 because there's no country where one person has everything. There are a couple countries that get close to it, but nobody's gotten to there yet. So that's basically what behind by it's just simply that, the worst case scenario ends up giving us an area here of 0.5, and 0 to 1 makes, sort of nicer than 0 to 0.5. Okay, again, I don't expect you to be able to compute a Gini coefficient. In order to do that, you would actually need to have a functional form for the Lorenz curve and use integral calculus, or more likely you would use some kind of numerical, approximation using, statistical software. So I'm not going to ask you to do that, but I do want you to understand that the further away from the line of equality the Lorenz curve is, the larger the Gini coefficient will be. All right. So the Gini coefficient is going to be some number between 0 and 1. It's scale free, because remember, we're talking about percentages here. We're not talking about any kind of units. So we can compare countries to each other. And that is helpful to us because it does allow us then to compare countries and just get a number. So if we get a country that has a Gini coefficient of 0.25, and we have another country that has a Gini coefficient of 0.7, right away we know, okay, that first country has less inequality than the second country. Okay, so let's take a look at some numbers. So here are, some Gini coefficients around the world. And oftentimes what people will do is just sort of, put it on a 0 to 100 scale instead of a 0 to 1 scale. It doesn't really matter. But all of these you can actually think of, the Gini coefficient for South Africa is actually 0.625. They'll call it 62.5. They're just putting it on a 100-point scale. Again, the Gini coefficient by itself is not useful. It's only useful in comparison to other places. So as long as we do the same transformation to every country, it's fine. Okay, but you can see here that you've got a lot of differences in inequality. So some countries that have really high Gini coefficients. So South Africa, 62.5. That's really high. That's like amongst the highest in the world. That is the highest in terms of most recent data. At some point, I think Namibia, not recently, but a few years back, had like a Gini coefficient of like 71. So we've never gotten to 100, but we're getting close. But you can see, some countries have really high levels of inequality compared to others, right? So you got some other places where Gini coefficients are much, much lower, half the size of some of these. So there's a lot of differences in inequality across the world. What I did here was created a heat map of countries based on their Gini coefficients. And so, the countries here in blue have Gini coefficients below 29 or smaller. The countries in green are between 29 and 35. The countries in yellow between 35 and 41. 41 to 49 in orange, and then anything above 49 in red. And what you see is we tend to see the lowest levels of inequality in sort of Northern Europe and Eastern Europe. You have also some low levels of inequality, for example, in Canada, Australia, and some places in Africa. However, you start to see higher levels of inequality in, so certainly in Latin America. The US has a pretty high level of inequality, China, Russia. And the highest levels of inequality tend to be in Southern Africa and in Latin America. On average, we do see higher levels of inequality in developing countries than we do in developed countries. And that's something we're going to get to in module 3.3. But it's not universally true. There are some rich countries that have really high levels of inequality, the US, for example, and there are some poor countries that have relatively low levels of inequality. Pakistan over here, for example, has a pretty low level of inequality. So, we don't want to universally say, yeah, developing countries have more inequality than developed countries. On average, yes, that's true, but there's a lot of exceptions to the rule. There's a lot of other things that influence inequality. Okay, so those are the three methods that we're going to use to measure inequality. And before I conclude, I just want to talk about, that we need to be a little bit careful that we're not putting too much on this statistic. It's good, but it's by no means perfect. So I'll give you an example of what I mean here. Here, I've got two Lorenz curves, Lorenz curve for country A, Lorenz curve for country B. And they're drawn in such a way that the area between the line of equality and the Lorenz curve for both countries is exactly the same. Although the shapes are different, the area is the same. So the Gini coefficient for both of those countries is the same. If you looked at them just looking at the Gini, you would think, oh, same level of inequality. But looking at the Lorenz curve actually tells a pretty different story. If you look at country A, the very poor in country A have a lower share of income than the very poor country B. However, if you look at country A, the middle class has a higher share of income than the middle class in country B. what is the difference there, right? Is it better that you have a strong middle class, such as in country A? Maybe that's the engine that drives economic growth, but is it worth the expense of having the poor being really, really poor in country A? All right. So if you have this, impoverished group that is so disenfranchised, maybe that could be politically destabilizing. Maybe this is a sort of situation where this group is forgotten, left behind, and that's the kind of group that foments some kind of political unrest. So you need to be, a little bit careful when looking at inequality. We need to see, where is that inequality actually coming from? And so that's why we don't want to just rely on the Gini coefficient. Sometimes it is helpful to look at the Lorenz curve. It is helpful to look at size distributions. Okay. And then we also need to be a little bit careful that the Gini coefficient is a single number for an entire country. And there's a lot of differences in inequality if we look within countries for particular groups. So for example, here what I've got is the evolution of the Gini coefficient for men and women in the US from 1967. And what we see is that for both men and women, there's been an increase in inequality. And this is, one of the stories of sort of American economic history over the past 50 years has been that we have become an increasingly unequal society here in the US. Most of this being driven by increases in income at the very top. Right. So it's not that the poor are doing worse, it's that the rich are doing a lot better. And you've had, big increases in, CEO pay and executive pay that have really been driving a lot of the inequality. And one of the reasons why we tend to see less inequality amongst women than we do amongst men is that there tends to be, more of a ceiling on, the kind of wages that women can achieve there. You don't have as many women in these sort of star high paying executive jobs as you do men. And so you don't see that, huge gaps between the richest and the poorest. We're certainly going to come back and circle back to this issue of gender equality later in this module. We'll talk about some of the reasons why that might be. But this here is a reflection that we need to be careful when we're looking at inequality that, we're not ascribing this to everybody in a group, right? Sometimes there's more inequality for certain groups than for others. And, you might look at this and say like, oh, that's good. Women have less inequality. It's actually bad that there's less inequality because it's a reflection of the fact that there's a huge gender gap in pay, especially at really high levels of wages and incomes. Okay. And then the last thing that I want you to note is that a lot of times people will conflate inequality and poverty. And but they're not the same thing. So I mentioned earlier that there's less inequality in Pakistan than there is in the US. True. That does not mean that the poor in Pakistan are better off than the poor in the US. Even though the poor in Pakistan have a larger share of total income, they're getting a larger share of a much smaller pie. Right? So total income in the US is much bigger than total income in Pakistan. And so even if the poor are getting, twice as much of the income share in Pakistan as the poor in the US, it's a bigger amount of income that the poor in the US are still getting. And so, in the notes, I kind of did some back of the envelope calculations and showed that, yeah, the poor are significantly better off in the US than they are in Pakistan. Looking at both inequality and poverty together is what we need to do. We can't just look at poverty by itself, just like we can't look at inequality by itself. So we need to consider them both. The next section talks about how we measure poverty. So until then, I hope you enjoyed this. See you later.